This is Group 8B's Lab Report 2.
The main goal of this lab was to design a circuit that had an LED light bulb and an electric motor in parallel with each other and designed in such a way that both the light bulb can light up and the motor can run at the same time. Also, a resistor made of Play-Doh had to be put into the circuit so that the light bulb and the motor still ran at the same time. As a group, we built a circuit following this criteria and then were able to measure the voltage and current across the Play-Doh resistor by using a multimeter. Using these values, we were able to determine the resistivity of the Play-Doh. In order to set up the design of this experiment, we used 4 1.5 volt batteries, an LED light bulb, a fan, alligator clips, and a resistor made of pink Play-Doh that was rolled into a 3 centimeter long and 0.785 centimeter squared cross-sectional area to make a circuit. Our circuit was set up with 4 1.5 volt batteries in parallel with the Play-Doh resistor, the light bulb, and the fan. Represented by our system schema, the Play-Doh, light bulb, and fan all interacted with the batteries via an electrical interaction, and represented by our power box, the Play-Doh, light bulb, and fan all received the same amount of voltage, but because the circuit was in parallel, they each received a different amount of current.
Play-Doh could not be made into a perfectly cylindrical shape. This would affect the calculated area using a larger error parameter, which would lead to either a less accurate resistivity of the Play-Doh. The wire inserted into the Play-Doh was not held in a secure place. This would affect the overall resistivity of the Play-Doh resistor because if the wires were loose, then it would make the flow of electrons even more difficult, therefore decreasing the measured current flow and increasing the resistance once later calculated. The alligator clips were not all completely secured. This would affect the measured current and therefore influence the resistance calculations due to the loss of electrons and not having the complete flow due to the gap in connection of the circuit. Resistance is the property that materials have that resist the flow of electrons. Resistors work by limiting the amount of current that can pass through it in a certain amount of time. This resistance creates a voltage drop across the resistor and reduces the amount of current that is passing through it. Play-Doh is a conductor, so it has resistance, which is dependent on its shape. It also has resistivity, which is independent of shape. This can be found using the relationship demonstrated by Ohm's law shown at the top of this slide. First, using measurements found using the multimeter, we were able to find the Play-Doh's resistance using Ohm's law. We found it to be 360.27 ohms. Then, by finding the cross-sectional area of the Play-Doh, we were able to find the resistivity of the Play-Doh, which we found to be 94.27 ohm meters. We were able to successfully make Play-Doh into a resistor while also allowing for the light bulb and fan to operate in the circuit. Our calculated resistivity of the Play-Doh was 94.27 ohm meters, and the overall calculated resistance of Play-Doh resistor was 360.27 ohms in the circuit.